We'll see today operations which will be done on a linked list. So many times we have seen we require traversing of list. In that, for printing a linked list, we have seen how to print linked list. Then you see counting number of nodes. In linked list. So we'll see just counting. We have seen already printing of linked list. We'll see counting of nodes in any singly linked list. Assume I have a linked list of some nodes this is first node. We have seen address of first node is must, and the last node's link field always will be null. Some information fields we will take. So this is a sample list, suppose. For counting of nodes, when the list is given, then we have to give the number of nodes in that particular linked list. In this case, if this linked list is input, then 3 will be the count. So how to do this counting? Always, whenever you count, we have to visit the node. If node exists, count will be incremented. Move the pointer, node exists, count will be incremented. Move, count will be incremented. But as this is last node, if you move the pointer, then what will happen? There is no node after that. So count returned will be 3 here. So how to do this? Traversing, always we have seen one temporary variable is taken. Temporary variable points to the first node initially. Now this will be moved in traversing. Never move first, because if you lose first, you will lose linked list. So one temporary variable is taken and this will be moved. So temp contains address of first node now. Which statement we write this? Temp is given first. Right? Now, when I say temp is pointing to this node now, means temp is not null here. So there node exists, you have to increment the count. Move temp, increment the count. Move temp, increment the count. So what we are doing when temp is not null, then we are incrementing the count, then moving. Not null, increment count, move. Not null, increment count, move. When you move, then temp will have null value. So as the logic used for traversing, for printing, the same logic goes here. Only the thing is, we have to have count initialized to 0. Count initialized to 0. Then what condition? When we are continuing this counting process, while temp is not equal to null, what we are doing? We are incrementing count plus plus. After incrementing, we are moving temp. Temp is given temp's link field. Now we have seen the structure for this node. That's it. This is central logic for counting. What will happen? See, first is given to temp. So temp also points to first node. Control comes here. Count initially is 0. While temp is not null. Whether temp is null here? No. When this condition is true. When true, it will come inside. Count, it was 0. So I'll maintain count here. Count initially was 0. Now it will be incremented to 1. Then temp is given temps link. Temps link, this is temp. Temps link field is this. What this stores? Next node's address. Right? So next node's address is given to temp. Means whenever this temp link, this contents of this field is given to temp, means temp now will point to this node. Right? Then again it will come here. Temp, not null here. Then it will go inside. Count plus plus. Count will be 2. Then temps link is given to temp. So temp will be pointing here. Whether temp is null? Not null yet. Count will be incremented. Count is 3. So temps link is given to temp. Temps link. What is temps link now? Null. So null is given to temp. It will have null value. So when it goes to while loop, temp not equal to null, but now it is equal to null. So it will control comes out of this loop, and you will have count after this loop. So you can either print count, printf count is equal %d, and here you can have count. So this is central logic for counting. Assume that whether this logic works when linked list is empty. What is condition for linked list empty? First will be null. First will have null value. First will have null value. So in this case, what will happen? See, first is given to temp. Means null is given to temp. Count is 0. Temp not equal to null, but it is null now. When empty list null. Null means this condition is false, it will come out of this loop. Printf count. What is current count? Count is 0, not changed. So if empty list is given, count will be same. If only one node is present, assume that only one node, and this is pointed by first. So what will happen? First is given to temp. Temp is pointing here now. Count is 1, so 0. Then temp not null? Yes, temp not null. Count will be incremented. Count will be 1. Temps link is given to temp. Temp link is null. Null will be given to temp now. When it comes again here, condition, and this will be false, it will come out and count printed will be 1. So for empty list it works, for this also it works. So this, how we can write function for this. This, if central theme is ready, writing function is very easy. How to write, how to convert this into function, that we'll see. Now see, what we are doing, what should be the signature of a function? For counting number of nodes, when I say somebody, I am giving the list and saying count number of nodes in this linked list. Means I am giving the list. What he should give me? That count, integer value. So my signature will be integer. I'll say count nodes. What I am providing to this? I am providing the list, address of the first node. So I'll say whatever structure I have defined for node, struct node star, I'll say start. This address I am giving. Now whatever we have written this will be same. Now I'll rewrite again this logic in a We have given list. Somebody has given me the first node's address. So when I have first node's address, I want to count. So this might be linked list given by somebody. This is list. This is given, this address is given to start. Now I have the first node's address. So what I have to do here, for counting nodes, I need one temporary variable always for traversing. So I'll declare one temporary variable struct node star temp. Then I'll say int count is required, one variable for counting, and that I'll initialize to 0. Now what is first step we have seen? Always this temp should be set which points to the first node. So here first node's address is in start. So start is given to first node. Right? Now while temp not equal to null. Why we are giving this capital? Because this is a constant defined in header file. Then what we have to increment this count plus plus, and then we have to move temp. Temp is given temp's link field. So this loop will count number of nodes. So after this loop, whenever control comes out of this, then I'll have a count number of nodes in that. So if I return that, that's it. Return where is the count in variable count. Return count and close this. So this is function for counting number of nodes. How can you give call to this function? If I want to call this function from any other method, what count nodes I am sending first. If in the caller I am storing first node's address in first field, then it returns me one integer value. That integer I'll collect in some C. So this is in caller. This is called, and then count will be returned to C, and I can print now this number of nodes or count is equal %d, and here C. So this code will be in caller from wherever you call. So whenever there will be call, control comes here. First, that contains first node's address will be copied into start. Then this happens, it will count, it will return the count. Return count will be in this C, and that we are printing. Right? This is one way where traversing is required. What is traversing? We have seen visiting each node once in a particular manner. For printing we have seen already. For traversing, this counting also we need traversing. See, we have seen how to count nodes. See, whether temp is required here. We have written this as per our explanation, whatever I have given. This is how temp is required and all these things. But when you write function, see, what is our aim? Whenever you have a linked list, suppose this is linked list given, this is first, and for this linked list I want to count the nodes. first I am sending, I am copying into start. So in this function, start can be changed, or this pointer can be changed. First should not be changed, but when I am passing this as parameter call by value, this is temporary now. So if I write P here, now temporary is not required, and in place of this temp, directly what I can do is I can write P. Now what change I have made here, temporary I have explained accordingly, I have written. But here whenever I write function, first is passed by value, that address will be copied here. Accordingly, though P we are changing, we require this for counting only. P we are changing, but we are not changing first. So temporary in this case, when you are writing as a function, that is not required. So this is sufficient for counting number of nodes whenever you write function for that.